Hello, people. This is Scale of the Universe. We shall start with the smallest form of existence that there is previously known.
And this is post-traumatic squirrel trying to help. Sorry, I'm all sick. When I'm sick, I can do something really cool with my voice. I can get really low and actually sound like a real person. See? I can sound like a real person. But only when I'm sick. Let's start.
This is quantum foam. There is the space-time theory. According to the space-time theory, quantum foam, which is also known as space-time foam, is the foundations of the fabric of the universe. This is a theory. It is in fact. Could be right, could be wrong. We'll just live with it. And also according to string theory, strings are one-dimensional, but vibrate in all other dimensions. This string, however, is not the same length. A string that you would see used for flying kites. That string is between 10 to the 32 power and 10 to the 33rd power times larger. The brain. According to string theory, brains exist in a certain number of dimensions. A zero-dimension brain, or zero brain, is a point. One brain is the string. A two-brain is a membrane, and so on. String theorists say that it goes all the way up to 11 dimensions. In Planck length, or lambda p, is a unit of length. There is also Planck time, which is the amount of time it takes light to travel one length in a vacuum. Zooming out to see more of the universe, we find our first subatomic particle. In fact, it is sub-quark particle. The neutrino. Neutrinos pass through the ordinary matter like you and me all the time. In fact, they're doing it right now. Neutrinos have no charge, so they are only affected by gravity, and that is a weak force in comparison. However, they are so small that they are barely affected. Some neutrinos go faster than light. The top quark. The top quark is the smallest quark, which means it is the most massive. It is almost 100,000 times as massive as the up quark, which is the lightest of quarks. The top quark's mass is over 1,703 billion electron volts. High-energy neutrinos are neutrinos with a higher energy and are larger. For more about neutrinos, go to the neutrino. This shows the average size is a whopping 15,000 times smaller. Bottom quark. The bottom quark is also called the beauty quark because it is so flawlessly beautiful. It is third generation and quickly decays into first generation quarks, like up and down. The charm quark. The charm quark and the strange quark are the second generation of matter. they will quickly decay into up and down quarks, which are the first generation of matter. The charm quark is charming. Strange quark. Strange quarks are, well, very strange. They are 50 times as massive as up quarks, but are still smaller. Isn't that strange? Very much so. Strange matter is made up of up, down, and strange quarks. Up quarks. There are 6 flavors of quarks. There are up, down, strange, charm, top, and bottom. The smaller a quark is, the more mass it has. As a result, the up and the down quarks are actually the lightest of the quarks. This up quark has a charge of +2 to 3, and the down quark has a mass and a charge of -1 to 3. Range of weak force. The weak force is one of the 4 fundamental forces of nature. It is the name that implies is the weakest. As distance increases, its strength continuously decreases. At just 10 atometers, the weak force is so weak, it is unmeasurable. This is the theoretical. Lengths shorter than this are not confirmed. All the objects that are smaller than this are unmeasured. The sizes that they appear are only estimates. Some things, like quantum foam, are merely just part of theories and are not fact. The proton. Protons are the first and most understood of the subatomic particles, and as such, protons are found within an atom's nucleus. They are 1,000 times smaller than the atom itself, and they have 2 up quarks and 1 down quark. Therefore, the proton's charge is +2 to 3 +2, 3, -1 to 3, which equals 1, a positive 1. Neutrons are found within an atom's nucleus. They are 1,000 times smaller, but their up and down quarks are different. Therefore, the neutron's charge is -1 to 3, -1 to 3, +2 to 3, which equals 0. Oops, I forgot the electron. Helionucleus. The helionucleus is thousands of times smaller than the atom, like a marble in a football field. The only reason matter feels solid is because atoms repel. If atoms didn't repel, everything would fall through each other. A chlorine nucleus. The chlorine nucleus has 17 protons. There are usually 18 or 20 neutrons there as well. Only rarely are there 19. I'm not sure why this is. No one is. The uranium nucleus is the highest natural element, and it is also has the largest nucleus of all the natural elements. Uranium-238, the most common isotope of uranium, has a half-life of 4.5 billion years, approximately the time the Earth has existed. A gamma-ray wavelength. Gamma rays have a very high frequency. They can come from radioactive decay. And by the way, it's not actually light blue. Hydrogen atom. The hydrogen atom is the most abundant element in the universe. It's usually just a proton and an electron. A hydrogen atom is so small you can't even see it with your naked eye, even if you try your hardest. The helium atom. Helium atoms, hydrogen atoms, are larger than helium atoms because more protons in an atom's nucleus pull the electrons in closer. However, additional shells increase the size of the atoms the most. The largest atom, cesium, has the most shells, but the fewest electrons. Francium is stated to as well, but francium has never been measured. This dot, or large circle in case, is the smallest thing visible to an electron probing microscope. And electron microscopes allow us to see very small things, some of which are smaller than the visible wavelength of light, like atoms. These things are invisible to a normal microscope. The angstrom. An angstrom, which is named after Swedish physicist Anders Jones Angstrom, is 1/10 of a nanometer. Sorry. The symbol for an angstrom is A with the symbol on top. I don't know what it's called. The angstrom is used to express the size of atoms. Water molecule. I'd like to think that whenever I drink water, I drink Mickey Mouse heads. Oh well. The cesium atom is measured by the distance of the nuclei in covalent bonds. The shells don't look actually like this. Cesium is the largest atom, but its atomic number is not the highest. The X-ray wavelength. X-ray wavelengths, although X-rays do not have the highest frequency, it's still a bad idea to bask in them. Just don't do it. Usually you should have a lead shield. The thicker the lead is, the more protection. However, there is still a chance some X-rays get through. Thicker lead just lowers this chance. Glucose is a simple sugar. Plants through glucose through photosynthesis and turn it into complex sugars. When we as humans eat plants or animals that have eaten plants, we eat complex sugars, which we break down into glucose again, which we use for energy. A phospholipid. Phospholipids are beautifully amazing little molecules, and if you have millions of them in your body, phospholipids are actually a special type of lipid that make up cell membranes. The phospholipid bilayer. Phospholipid bilayers are cell membranes made of, well, phospholipid bilayers. And can form naturally because the head attracts to water, and the tails repel from water. As a result, tails clump together, forming the bilayer. DNA. A single human cell contains 3 meters of deoxyribonic nucleic acid. That DNA